Hello and welcome to the first video of section 2.9 on linear approximations. In this video, we return to the basics, recalling that a tangent line to a curve approximates that curve. Suppose we found the tangent line to a curve at 1. As we increase our magnification, we see that for x values very near 1, the tangent line and the curve are very close. We know how to describe the tangent line of a function f at the x value a. It is a line which passes through the point a, f of a, and has the slope f prime of a. Writing the equation of the tangent line in point slope form, we have that y minus f of a equals f prime of a, x minus a. Remember that a non-vertical line is a function. Therefore, we solve for y, and we give the function a name, L sub a, L for tangent line, and a for the location of the tangent line on the curve. At this point in the semester, we have a lot of practice calculating tangent lines. We formalize this with the linearization definition. The linearization of f at x equals a is literally the tangent line of f at x equals a. L sub a is a convenient shorthand because there are many tangent lines for a function. We must be specific about the x value we're going to find a tangent line at. A few things to note. If a function is not differentiable at a, that is f prime of a does not exist, then the linearization, L of a, doesn't exist, as its slope is not defined. As we witnessed earlier by zooming into a graph, the closer a value b is to a, the nearer L sub a of b is to f of b. This is why this section is called linear approximation. L of a is a line which approximates our function when values are close to a. In fact, if x is equal to a, then the linear approximation and the actual value coincide. Linearization is a tool which allows us to view potentially complicated functions as simple lines, at least when we're close to a specific value. Calculating with lines is a breeze. After all, it's only addition and constant multiplication. No square roots, no higher powers, no trigonometry. Take the example of the square root function. We can find the linearization by first finding the derivative. For any x value a in which f is differentiable, we can find the linearization of the square root function. Now we can use this linearization to provide a reasonable estimate of the square root of rational values. Take, for example, the square root of 16.024. The nearest value to 16.024, for which we can quickly calculate a square root, is 16. Let's take a equals 16 in our linearization. Notice that 16 and 16.024 are very close, so we should expect that the square root of 16.024 can be approximated by the linearization. We plug 16.024 into our linearization, subtract, divide 0.024 by 8 and get 0.003, to which we add 4. Our linearization anticipates a value of 4.003 for the square root of 16.024. which happens to have an actual value very close to 4.003. Our linearization function L sub a is just a formalization of the tangent line. Keep in mind, the tangent is a linear approximation of a curve.